Hi everyone, once again welcome back to our class. Now we are going to discuss about some numerical problems based on the kinematic equations of motions. Here these kinematic equations, v is equal to u plus at, s is equal to u2 plus half at square, v square minus u square is equal to 2as, and sn is equal to u plus a into n minus 1 by 2. These from some problems, these formulas. Now here very simple explanation, numerical, very important for JEE mains and Neet and MCET. Okay, now here question, see here question. First of all, a particle is at x is equal to 5 meter at t is equal to 0 seconds, okay, and x is equal to minus 7 meter at t is equal to 6 seconds, and x is equal to positive values here, plus 2 meter at t is equal to 10 seconds. Find the average velocity of the particle. Find the average velocity of the particle during the time intervals. During the time intervals here, time intervals t is equal to 0 seconds to t is equal to 6 seconds. One condition. This is the conditions. Now t is equal to 6 seconds to t is equal to 10 seconds. These are time intervals. Next to third question, t is equal to 0 to 10 seconds. T is equal to 0 to 10 seconds. This is the time intervals. Now in this problem, three problems in this case here. Now first of all, displacements of the particles. Here x is equal to 5 meters, x is equal to minus 7 meters, x is equal to 2 meters. Here x1, x2, x3. These are here x1, x2, x3. Next, the time intervals here. t1 is equal to, first of all, 0 to seconds. t2 is equal to, for example, 6 seconds. t3 is equal to here 10 seconds. Now here answer very simple. Time intervals here. t1, for example, t1 is equal to 0 seconds. Conditions here. t2 is equal to 6 seconds, and here t3 is equal to 10 seconds. t3 is equal to here 10 seconds. Now here t1 is equal to, for example, 0 seconds. How much distance here? 5 meters. So this one here, x1 is equal to 5 meters, and here x2 is equal to negative values here, negative 7 meters, and here x3 is equal to, and x3 is equal to here, x3 is equal to 2 meters, x2 is equal to 2 meters. This one here, x1, x2, x3, t1, t2, t3. This is the time intervals. First condition, first of all, average velocity. What is the average velocity? The ratio of, very simple, the ratio of change in displacement to change in time. This is called as here average velocity. So first of all, average velocity formula here, average velocity is equal to delta v, delta x by here delta t, that is equal to here x2 minus here x1, t2 minus t1. This is a average velocity formula. This one here average velocity formula. Delta x by delta t, that is equal to change in displacement or change in positions. Delta t means here change in time intervals. Change in time intervals, that is equal to x2 minus x1 by t2 by t2 minus t1. This is a formula. Now first of all, first condition here, first condition t is equal to 0. Here t1 is equal to 0, t2 is equal to 6 seconds. Is the position of this seconds here. t1 is equal to x1 5 meters, and this is the t2, that is equal to here 7 meters. Now value substitute. Very simple. Here first one, here first condition x2, here first condition, this is a t is equal to 0 seconds, that is equal to here t1 is equal to 0 seconds. Next t2 is equal to here, first condition, t2 is equal to 6 seconds. Next here t1 is equal to 0 seconds. So then how much here? 5. So this one here x1 is equal to 5 meters. x1 is equal to 5 meters, and t2 is equal to 6 seconds. T2 is equal to here 6 seconds. Displacement here minus, this is a x2 is equal to minus 7 meters. Now this values here substituting here. Now the average velocity during times here, first one answer, average velocity here during time intervals, okay, here t1 is equal to 0 second to t2 is equal to here 6 seconds. Display positions here, t1 is x1 is equal to, for example here 5 meters, and here x2 is equal to minus 7 meters. Now the formula, this is a formula. Now this value here substituting, average speed is equal to average velocity is equal to here x2 minus x1 by t2 minus here t1, simplies average velocity is equal to here x2 values here minus 7 minus now x1 values here just to 5, okay, 5 by t2 values here 6 seconds and minus t1 values here 0 seconds, that is equal to average velocity is equal to here minus 7 minus 5, so minus 12 by 6 minus 0, 6 minus 0, that is equal to 6, so 6 1 ja 6 2 ja, that is equal to minus 2. So the average velocity of the particle, first condition answer here, average velocity is equal to minus 2 meter per second, this is a first answer, this one here first answer, okay. Next condition, second condition, here t is equal to 6 seconds, t1 is equal to here t2 is equal to 6 seconds and t3 is equal to 10 seconds. The position of the particle or displacement of the particle, here x2 is equal to this one, x3 is equal to here this one. Now first of all note this one, next one, okay. Next, average velocity here t2 is equal to second case 2, this is a case 2, t2 is equal to 6 seconds and here t3 is equal to 10 seconds, and here x2 is equal to the position of the particle at 6 seconds here, this is a x2 nothing but here this one x1, this is a x2, this is a x3, okay. x2 is equal to minus 7 and x3 is equal to plus 2 meters here minus 7 meters. So average velocity here, average velocity during times, average velocity during times and answer here, that is equal to x3 minus x2 by t3 minus t2. So x3 values, x2 values here substituting, or t3 values here, t2 values substituting, after we will get the average velocity of the particle. Here x3 values here plus 2 minus, here x2 values here minus 7, so minus 7 by here t3 values 10 seconds minus t2 values here 6 seconds. Now simplies average velocity is equal to minus into minus plus, minus to minus plus, that is equal to here 2 plus 7 by 10 minus 6, that is remaining 4, that is equal to 2 plus 7 9 by 4, so 4 1 ja 4 2 ja, remaining 1, so remaining 1 to remaining 5, 2 2 ja 8, so 2 5. So answer here average velocity. Second average velocity is equal to here 2.25 meter per second. So 2.25 meter per second. This is the answer of B option. So the answer of the second average velocity is equal to 2.25 meter per second. Third case here, t is equal to 0. This is the t1 is equal to 0 seconds and t3 is equal to 10 seconds and x1 is equal to 5 meters, x3 is equal to here 2 meters. So third case, note this one first of all. Okay, now third option, condition C. Here answer C answer. Here t1 is equal to 0 seconds and t3 is equal to 10 seconds and here x1 is equal to 5 meters and here x3 is equal to 2 meters. So average velocity is equal to here x3 minus here x3 minus x1. This is the conditions. So now t3 minus here t1 values here substituting, average velocity is equal to x3 values here 2 minus x1 values here 5. So x1 here 5 by t3 values 10 minus t1 values 0 seconds. T1 is equal to 0 seconds. Now simplies here average velocity is equal to 2 minus 5 remaining negative values, so minus 3 by 10 minus 0, so 10, that is equal to average velocity is equal to, so denominator here 10, so numerator 0 minus 0.3 meter per second. 3 meter per second. This is the answer. This one numerical problems. Okay, very simple. ఇక్కడ కండిషన్స్ ఇచ్చిండు. కండిషన్ x1 is equal t1 is equal to 0, t is equal to 6 seconds. Second condition లో t is equal to 6 seconds to time changes, t is equal to 10 seconds. Third condition లో t is equal to 0 seconds to t is equal to 10 seconds. So ఆ పొజిషన్ తీసుకొని అప్లికేషన్ చేస్తే రిమైనింగ్. సో నెక్స్ట్ ప్రాబ్లం, నోట్ దిస్ వన్. నెక్స్ట్ ప్రాబ్లం, next problem, see here, see there. Now the displacement x, the displacement here x of a particle at the instant when its velocity v is given by v is equal to under root of 3x plus 16. Find its acceleration, okay, acceleration and initial velocity. Find the acceleration and initial velocity of the particle. Here given data, the velocity of the particle v is equal to under root of 3x plus 16 meter per second. Okay, meter per second. Now the displacement of the particle here x, this is the displacement of the particle here x. Find out the acceleration of the particle and initial velocity of the particle. How to solve out this type of problem? Now first of all, the kinematic equations of motions. Here three equations, v square minus u square is equal to 2as. Here Sn is equal to u plus a into n minus 1 by 2, and here s is equal to u2 plus of at square. These formulas compared to the any given problem. Now in this problem, compared to the equations, now first of all, answer velocity here v is equal to 3x plus 16 meter per square. Now this is a squaring on both sides. This is one here squaring on both sides. Now means here v square is equal to here simply v square is equal to 3x plus 16. 3x plus 16. So the 16 taken left side. The 16 taken as left side. So simplies v square minus 16 is equal to 3x. Just 3x. Now this is a converting in formula. V square minus u square is to 2as formula. So that means here v square minus 4 square is equal to just 3x. Here x is a displacement, u is a 4 is a initial velocity of the particle. Initial velocity of the particle. Here this is a v means a final velocity of the particle. Now this one equation, this is a equation 1. For example, this one is equation 1. Now v square minus u square is equal to 2as. Here a is a acceleration of the particle. Acceleration of the particle. S means here displacement of the particle. Now this is a equation, for example 2. This equation 2. This equation here 1. Equation 2 comparing the equation 1 compared to the equation 2. So this equation compared to the equation 2. So from here from 192. So here u is equal to just u is equal to 4. This is the initial velocity of the particle. Next here 3x is equal to 2as. Here s means displacement of the particle. Here x means here x is a s means displacement of the particle. Here x is a displacement of the particle. Now here compared to this two. So here initial velocity is equal to, now this is a 16. So just simply u is equal to 4 meter per second. 4 meter per second. So this is the initial velocity of the particle. Initial velocity of the particle u is equal to 4 meter per second. Next one, the compared to the here 3x is equal to 2as. So s is a, here x is equal to x. That means here remaining constant terms here 2a is equal to just 3. 2a is equal to just 3. So here 3 is equal to 2a. 3 is equal to here 2a. Simplies here a is equal to 3 by 2. A is equal to here 3 by 2. So 2 1 ja remaining 1. So 5. So that is equal to acceleration of the particle. A is equal to here 1.5 meter per second square. So answers here, for first of all acceleration, here answers here acceleration A is equal to 1.5 meter per second square, and initial velocity here u is equal to just how much here then 4 meter per second. 4 meter per second. This is the answer. This one here answer. So very simple. Anyone compared to the given problems. Now next problem. Note this one first of all. Next problem. Next problem. See there here. Very simple problem. If Sn is equal to 2 plus 0.4 n. 0.4 n. Okay. This is a number seconds. Okay, find initial velocity here. Find initial velocity and acceleration. Find initial velocity and acceleration. How to find out these two values? How to solve these two values? Initial velocity of the particle and acceleration of the particle. Now first of all, here given data here Sn is equal to 2 plus 0.4 n. Okay, now here formulas. Sn is equal to formula here. Sn is equal to u plus a into n minus 1 by 2. This is a formula. Now this formula compared to this one. So this write this in form of this equation. Now this one here simply u plus here inside multiplication, here a is a inside multiplication, a n minus here a by 2. Now simply here this is a positive values, this one here negative values, a by 2. Okay, here plus a n plus here a n. So this equation, Sn is equal to this formula 2 plus 0.4 n. Here Sn is equal to u minus a by 2 plus an. So this equation 1, this equation 1, this equation 2. Now compare the equation 1 to equation 2. So comparing here, comparing equations here, equations 1 and 2, here 1 and 2, 1 and 2, here an is equal to 0.4n, that is equal to a is equal to here simply 0.4 meter per second square, the acceleration of the particle. Here a is the acceleration of the particle, this one here, this is a compared to the this one. So n cancel, compare equal just a is equal to just to here 0.4 meter per second. So acceleration of the here, acceleration of particle, for example particle here a is equal to simply 0.4 meter per second square, meter per second. This is the acceleration. Next, compared to the u minus a by 2 is equal to here 2, u minus a by 2 is equal to here 2. So here u minus a by 2 is equal to here just 2. Here a value is here 0.4, a value is here 0.4. So this value is here substituting, simply u minus a value is here 0.4 by 2. Okay, 2 1 ja 2 2 ja is equal to here 2, simplies here u minus this is the remaining terms 0.2, remaining terms here 0.2. So 0.2 is equal to just to 2. Okay, is equal to here 2, is equal to here 2. Now initial velocity u is equal to here, initial velocity u is equal to 2 plus here this is taken right side, so positive 0.2. So finally final value is here initial velocity of the particle 2 plus 0.2, that is equal to 2.2. Okay, now initial velocity here u is equal to 2.2 meter per second, 2.2 meter per second. This is the answer. So here a is equal to, this is a 0.4 meter per second square, this one here acceleration of the particle or acceleration is equal to 0.4 meter per second square, initial velocity u is equal to 2.2 meter per second. This is the questions. Next class continuation is the these are numerical problems based on the kinematic equations of motions. Now next class continuation, the average velocity, average speed, the some problems and equations. Okay, చూడండి, సబ్స్క్రైబ్ చేసుకోండి, మీ ఫ్రెండ్స్ కూడా షేర్ చేయండి. ఓకే, థ్యాంక్ యూ, ఆల్ ది బెస్ట్.